What you see in this picture is a good representation of what I saw in a town where I was brought in as a contract inspector. Now, this is not new construction, but I wanted to point this out because it becomes a big issue and it gets turned down a lot. I don't understand why inspectors have so much trouble understanding the difference between bonding and grounding, and especially when it comes down to gas piping. Now, what you're seeing here is the contractor called me up all upset because he said the inspector wanted him to drive a ground rod and then run a equipment grounding conductor from the rod to the gas pipe. Now, what had happened is he put in a new air handling unit in this house, and the inspector went in and asked about how it was bonded to the system, and the mechanical contractor was at a loss because he's not an electrician. So he did what the inspector told him to do, and he sent me a picture. It looked very similar to what I found right here that you're looking at. And it's absolutely ridiculous in my opinion. And we got to get better in training for everybody and understanding what bonding and grounding is all about. And also understand that this actually becomes a hazard the way this is done. So we're going to go through some code issues, talk about a couple of things, and kind of address this. And I want you to kind of take this and apply it to your day-to-day activities. So let's begin by looking at our electric code. Article 100 defines bonding as the permanent joining of metallic parts to form an electrically conductive path that will ensure electrical continuity and the capacity to conduct safely any current likely to be imposed. That's a mouthful. Section 250-104B reads as follows: metal gas piping. Each above ground portion of a gas piping system upstream from the equipment shutoff valve shall be electrically continuous and bonded to the grounding electrode system. So that's what our code says. Now let's look at the fuel gas code. Fuel gas code, which is NFPA 54, which is typically not adopted. That's a good thing to realize. It's going to read though in G2411.1 and 310.1, pipe and tubing other than CSST. Alright, other than CSST. Each above ground portion of gas piping systems other than corrugated stainless steel tubing that is likely to become energized shall be electrically continuous and bonded to an effective ground fault current path. Gas piping other than CSST shall be considered to be bonded where it is connected to an appliance that is connected to the equipment grounding conductor of the circuit that supplies the appliance. Alright, that's a big question right there, right? It asks a lot. So using this language, many electrical contractors and inspectors provide that gas piping systems are not required to be bonded by the NEC via a separate bonding jumper. They argue that they are bonded by the equipment grounding conductor in the circuit feeding the gas appliance that is likely to energize it. Now, CSST has a separate bonding requirement based on the manufacturer's instructions. All right, this is not in the NEC. For this reason, bonding by means of the equipment grounding conductor run to the appliance does not meet the requirements of the bonding metal gas piping to the grounding electrode system, and that's in my opinion. I used to be like everyone else. I considered the fact that if the equipment had electrical connections somehow, the equipment grounding conductor that was there was sufficient. But as I research this more and more, I see now the reasoning behind requiring the bond. And since we're talking about it, we're going to talk a little bit about this CSST. The problems you got, like in the picture you see, this is an arc that occurred from a lightning strike to nearby at this house. Electric arcing and the CSST risk. This corrugated stainless steel tubing, commonly used in modern homes, features a very thin metal wall. If not properly bonded, the lightning energy entering the home will arc between the CSST and other grounded metals like HVAC ducts or water pipes, and it can cause a puncture, which of course then leads to gas getting out, and of course then leads to a house fire. There is history and lots of problems that have been identified with the CSST systems being installed and used for gas piping systems in buildings. Currently, there are efforts underway to kind of deal with this in its different aspects. CSST piping by itself is a great material. It's easy to run. It saves people lots of money. But it's got its problems. And I think history is going to show, in my opinion, that CSST piping is probably going to be a thing of the past very soon. One of the interesting features about the CSST piping, is that it does specifically require that it has to be installed per manufacturer's installation instructions. There's all kinds of criteria. So every system has a little bit different way of being used. What you get training on one brand of CSST piping may not apply to all. A good example is we got yellow jacketed CSST, we got black jacketed, and some say the black jacketed CSST doesn't require a bond in quite the same way. So the inspector's now left with having to decide, okay, I've got CSST piping in this home, so what do I do? Well, you're going to have the manufacturer's installation instructions. I think this is going to go the way of truss design drawings. We're going to have the documents available on site for the inspector when they go out to look at everything. NFPA 54 is the National Fuel Gas Code, and it should be noted that NFPA 54 requires that manufacturer's installation instructions must be followed in addition to local codes, often from the utility and the gas supplier and their regulations. Now, to touch on a couple of things, I do want to point out that as far as the bond goes, you should have them sand or kind of remove the coating or any paint or anything like that before you put the clamp on. The paint must be scraped down to bare metal so you can make sure you get a good bond. That's one point. Now, getting back to the CSST, one of the things you look for too is that grounding clamp. It doesn't need to be on that thin metal tubing. It should be on the fittings, the hard fittings above it, brass or black iron, whichever one it may be. Now, for inspections in your area, the best thing to do is get with the local authority having jurisdiction and the gas utility and see what the requirements are. That's going to kind of dictate what's done. Every jurisdiction, it seems like, is having a little bit of trouble with this, and they're all trying to come up with something that's very uniform as far as application of the code. But again, it comes down to interpretations. So where does this leave us as far as the example that we started off with? This, of course, is a thumbs down as far as I'm concerned. If I were looking at this installation, I would put a fail and then ask for whoever did this to give me a call. I'd love to talk to them. You cannot use an independent ground rod just for the gas piping. You just can't do it. I've seen this happen also where I had a guy once many years ago. They wanted to have a bond for the pump motor on a Whirlpool tub under a house, and the inspector wanted him to run another ground rod and run a conductor from the bonded clamp or the grounding clamp on that motor to that ground rod, independent of everything else. And again, this flies in the face of the whole purpose that we do equal potential bonding for the house. All grounding electrodes for a home must be tied together to create equal potential bonding. Again, we want uniform voltage, either increase or decrease. According to the NEC and the fuel gas codes, metal gas piping must be bonded. That's what we have to live with. And it's got to be bonded to the home's main electrical grounding system. It cannot be an independent grounding electrode, which is what you see in this picture. You must bond the gas piping to the main electrical panel or to the existing grounding electrode system using an appropriate size wire, typically solid copper, and an approved clamp. Installing a standalone ground rod for the gas piping actually creates different electrical potentials between the gas line and the electrical system. This could increase by shock hazards and also the risk of the gas line arcing if a lightning strike or a power surge should occur. So that concludes this video. We've got a whole host of other videos. Actually, go to the site and look over them. There's quite a few there for you to learn from. Please like and subscribe. We need to go over all this with you as much as we can, and let's try to avoid unnecessary failed inspections on the site. And that saves everybody time and money and a little bit of aggravation.